Okay, so we've got a problem here dealing with modeling with mathematics, and there's a lot going on. In fact, this problem has taken me a while to think about because it tries to model what would actually happen. So it's not going to be a nice, neat, linear scenario, but we're going to try to model it with a linear equation. So our goal here is to represent this, right, or to model this situation with a linear function. That's our goal. We're trying to connect these two to make a prediction. So what's happening in this problem? Well, the idea is that you're selling corn at the market, and every time you go to the market, you can see here what they're doing is the price is changing. In their table, the price is going up each time by 50 cents, right? Starts at $1 and it works its way up. Now the leftovers, we'll jump to that one next. As the price goes up, what's happening? Well, there's also more and more leftovers. In other words, they're able to sell less, right? If you're charging more, it might be difficult to sell your crop. So you would have more leftovers. That's the idea, right? So if we charge $3 here, there's 210 dozens of corn left over. But if we only charge $1, right, there's 40 dozens left over. So you can think about that in terms of profit. I mean, if you're selling everything for $1, you might sell on the demand side 200 dozens, right? So you'd make $200. But here, and this is something to observe, if you charge $3, well, you'll only sell 80 dozens. But how much money would that be worth? Well, right, $3 per dozen. And you're selling 80, that's $240. So you sell less, but you make more. So in terms of the business, that's what you would be thinking about, balancing demand versus price. Here, we're going to try to model that to really help us make predictions about what's the best choice. So we kind of answered A already. They say, why do you think the demand for corn decreases, right, as the price goes up? That's a negative correlation or a negative slope, right? Here I would say price is X. So I'm going to associate the price, choose a different color, price with X. Why? Because you choose the price. That's the independent variable. And the demand and the leftovers can both be seen, demand and leftovers, as your y variable. In other words, they depend on the x, so we can think of them as y variables. So anyway, if x is increasing, the leftovers are increasing. That's a positive relationship, but the demand is decreasing. So price increases, demand decreases. That is called a negative correlation. Versus choice B, which I'll put a check mark here. Choice B, which is, okay, why do you think leftovers increase as the price goes up? Well, for the same reason, right? As price goes up, the demand goes down and you'll sell less, so you'll have more left over. So that's that connection right there. Now things get a little bit tricky, right? Write a linear equation that models the relationship between demand and price. Well, we want to figure out some connection between like the demand at each stage here and the price, and that's our negative correlation. So I would start by setting up a table, and then we'll look at a graph to kind of understand what's happening. So in this case, y refers to demand, and x will always refer to price. But let's look at our table. Right here, when our price is $1, our demand is at 200. But then what happens? If we raise the price to $1.50, our demand drops to 175. If we increase our price to 2, right, we're increasing the price by 50 cents each time. What happens? Well, the demand keeps dropping. 140, 120, 80, and 60. And that's not linear, right? Think about that. Every time you go to the market, there's going to be different people there with different amounts of money. So we're not going to have a nice, neat relationship. But we do have something that we can approximate. And I would say the approximation is, okay, well, here I notice it decreases by 25. Here it decreases by 35. And here it decreases by 20. Here it decreases by 40. Here it decreases by 20 for each 0.5. So our slope for this is what? Well, slope is the difference in y over the difference in x. And our difference in y will come to in a moment. But delta x is always 0.5. It's always a half. What I would do is probably a reasonable step here is to average, right, these changes right here. So if you take out a calculator, right, you do it quickly. 25 plus 35 plus 20 plus 40 plus 20. It's 140. That's averaging 5 changes, not 6 numbers, but the changes, the 5 changes divided by 5. So it seems like our average change is 28. So what's our slope? Well, it's 28 or negative 28 for every 0.5. So divide 28 by a half, and we get an approximate slope. We get what? Well, negative 28 divided by a half is really negative 28 times 2, and that is negative 56. So it seems that our slope, right, we're saying we're going to lose demand by 56 for each what? Well, for each dollar that we increase by, right? Because we're thinking of 0.5, it's 50 cents or a half a dollar. So this is our rate in terms of each dollar. So we're almost done with the equation. The thing that's tricky, though, I think, especially in this equation, is how do you start your demand? I mean, in other words, what would the demand be at 0? And that's quite tricky. Because if y equals mx plus b, right, our slope is about negative 56, so it's negative 56x plus b. Now normally, if I said let's find the y-intercept, you would say x equals 0. But think about what that means for a moment. If x is 0, that means your price is 0. What happens if price is 0? Well then, if price is 0, you technically might have unlimited demand because people just take everything you have. So it's tricky, right? You might even say we can't pick a point for 0, and you might be correct. But remember, we're modeling with mathematics here. So for me, what that means is that we're trying to set up a line that represents the clearest trend, right? A linear regression line or line of best fit for these points. So let me just show you what I mean. I'm going to use this program really quick called Geogebra. So if we have 1 point 1, 200, think of that as when the price is 1, the demand is 200. That's our point A. And then we can keep going. If my point is 150, my cost is 150, my demand is 175. If my cost is $2, my demand is 140. If my cost is 250, I'm just plugging these points in. My demand is 120, and we'll finish up. My cost is 3. Right, my demand is 80. Oh, one more, sorry. And if my cost is 350, my demand is 60. Okay, so let me change this scale right here so you can see this a little bit more clearly. Oops. There we go. Keep going, so you see a trend here. And this is, it's difficult to set this line up, but you can see what's happening. These points don't really fall onto a straight line. But by trying to set a line, right, that's our linear approximation. So let me just try to get that image down here. Okay, scale it down. Okay, so the idea is that when we get a line of best fit, we're saying, well, where would the line, right, kind of be to fit all these data points? And there is a mathematical way to do that. We're just building on your intuition. I would say it's not down here, right? It's not up here. It's got to be kind of between all the points, like maybe right here. And maybe you're frustrated with that concept, but this is our approximation, right? And this is my way of finding about where the y-intercept would be if we follow this linear trend, right? So this is our y-intercept, 0, about, let's say, 260. That means your highest demand, or following this trend, is 260. It doesn't really model what will happen, though, if you charge $0 because you could give away everything. But this seems to be the line that predicts what's going to happen based on a price that you choose. Now, the reverse is going to happen with the leftovers, right? So in this table, everything is decreasing. Now things will start to increase. Let's set that up down here really quickly because I've only got a minute or so left. So here, the price is X, right? And then now we're looking at leftovers, and that's Y. So leftovers, Y, are increasing with each price increase because we're selling less. So we have 40, 75, 40, 75, 125, sorry, 125, 175, right, 210, and then 260. Okay. And I know the prices, right, are 1, 1.5, 2, 2.5, 3, and 3.5. Same idea as before. We don't have a constant increase because we don't know who's showing up, right? Everyone buys different amounts of corn, has different likes, different amounts of money, but we can average the changes to kind of get a sense of what the slope might be. So for every time x changes by 0.5, again, what's our change in y? Well, here it's 35, here it's 50, here it's 50, here it is 35, and here it's 50. So now we average these up. Again, 35 plus 50 plus 50 plus 35 plus 50. We get 220 divided by 5 changes. It's about 44. In other words, 44 divided by a half, which is 88, that tells me my slope. It just says that as I increase my price by $1, I can expect to have, on average, 88 more leftovers. And you can see it right here. From 1 to 2, it's about 88, from 40 to 125. From $2 to $3, it's about 88. Again, on average. So now we just quickly can set this up. This is our last thing here. Now these points are quite different, right? These are not like the points before. Here we'll have a positive correlation. Let me just change the window size. So now here are our points. We have 140, and we have 1.5, sorry, 75. And usually you would only need 2 points for a line, but I'm trying to show you the difference between the line and what's actually happening, because we're modeling what's happening. We're not actually saying this is linear. It's close to linear, but not actually linear. Hang in there, almost done. 3, 210, and 3.5, 260. Okay, so here's the last thing. And you can see the difference, right? Now we have a positive correlation or a positive slope. Remember, the leftovers are going up, right, as the price is going up. So let's just model this real quickly. So before, again, we had a line of best fit for the demand. It was decreasing. Now we have a line for leftovers, increasing. And this is maybe a little weird, right? Here we're going to get what? Once we continue down here, we're going to get a negative y-intercept close to about negative 50. So now we have a new equation. This is where we finish up. Y is equal to about 88 times x, or the price. You can say L equals 88p minus about what? About 60 or 50. And you can even plug it in. I'll say about 50, sorry. And it's close to our point. So if you plug 1 in, you get 1 times 88 minus 50. It's about 30 or 40 leftovers. If you plug 2 in, it's about 160 plus 16, or 176 minus 50. It's about 125 leftovers. So it works. But we're modeling, so there's got to be a difference. You can see the difference between the lines and the points. Things won't fit exactly. Anyway, so we've set the graphs, we set the equations, we've answered the questions. It's just a reminder that math is not as neat as we might expect it to be, but we can use it to model reality. And you know, reality is sloppy, reality is crazy. It can't always be perfectly linear, and this is just an example. Thanks.